Hello everyone. In today's lecture, I'm going to discuss about unit vector and addition of two vector. Addition of two vector means a resultant of two vector. If two vector is acting at a point, then how to calculate resultant. In previous lecture, we have completed about scalar and vector. That was definition part, scalar and vector, and also we discussed about some properties of vector. Okay. So in this part, we are going to cover unit vector and addition of two vector. So first one is unit vector. Unit vector is a vector which has magnitude only one. Means magnitude will be unity here. So it is a vector. It is a vector having magnitude equal to 1. Equal to 1. It will represent only direction because magnitude of this vector is 1. If I am multiplying this unit vector with any number, any scalar value, so that will become vector of that much magnitude. Means there is no unit, there is magnitude of this unit vector is only 1. So I can also write here, it represents direction only. Direction only. Okay, so this is a vector having magnitude equal to 1. That means it represents direction only. For example, if I am saying, let's understand first representation, then I will give example. So unit vector along a vector A is represented by A cap. That means if I want to represent vector A, so vector A means magnitude and direction. Direction is A cap. So we can write here A cap equal to vector A upon magnitude of this vector A. This magnitude is also written in this form. Okay. So if I am writing unit vector along vector V, unit vector along another vector V, so I can write here B cap. So again here B cap will be vector B upon magnitude of this vector B. Okay. So if there is any vector you want to find out unit vector along that vector, so what you have to do? This vector upon magnitude of that vector, you divide, you will get unit vector. Okay. So for example, if I am saying force 10 Newton is acting on a body in east direction. Okay. So meaning force 10 Newton acting on a body in east direction. So we can write this force equal to magnitude of this force and east direction. So we have to write here east direction. Okay. So unit vector when I am calculating along this force direction. So unit vector is force upon magnitude of this force. And what is force here? 10 Newton, east direction. So we can divide here. Magnitude of this force is only 10 Newton. So this 10 cancel. I am getting here east direction. So what is the conclusion here? That unit vector represents direction only. So this force was acting along east direction. So I am getting here unit vector only east direction. That means this is clear that unit vector represents direction only. If you are multiplying, later on I will see a multiplication of vector. So here, if you multiply any scalar with vector, unit vector, so that will become a vector and magnitude of that vector will not affected by multiplying this unit vector. Here, so overall this represents direction only, and this is a unit vector having magnitude only and only 1. Okay. Next one, unit vector along unit vector along coordinate axis. Unit vector along coordinate axis means unit vector along x, y, z. Okay. So axis we have taken like this. This is x, this is y, this is z. Okay. So this is three axes I am taking here. So unit vector along this vector I vector, this x vector is defined by I cap. Okay, any unit vector means any vector, unit vector you are taking along x, so we have given a special name. Okay, that is I cap. Unit vector along y is j cap, so along y cap, y j cap, along z k cap. Okay, so if I am extending it in opposite direction, means let's extend this one. So this will be of course minus z, this will be minus x, and this will be minus y. So I can write here unit vector along minus j is minus k cap, minus x is minus I cap, minus y is minus j. So this is how unit vector is defined along coordinate axis. Means x axis, along x axis, if there is unit vector, so I will write like this. Here this is x axis, this one y axis, this one z axis. So unit vector along x direction I have to represent, so I will represent this one. This is I cap. Magnitude of this I cap will be, of course, I cap magnitude will be 1. Here along this direction I will represent by j cap. So again magnitude of this j cap is 1, and here in this direction I will represent by k cap. So of course magnitude of this k cap is also equal to 1. So here unit vector magnitude will be always 1, and in coordinate axis we have assumed along x I cap, along y j cap, along k cap. Okay. So if I'm giving example that a force is acting along x direction, of magnitude 10 Newton, then how will I write force? Then find force. So force is a vector quantity, so vector means this is a force. What is magnitude of this force? 10 Newton. 10 Newton into, we have to put direction. So direction is along x. Along x, so direction I will put here only I cap, because along x direction is given by I cap. So if I am multiplying I cap here, it will not affect the value. It will become a vector quantity. So this one is magnitude, and this one is direction. Okay, direction. So this is how it is defined. Okay. So similarly, if I'm saying another example, let's say let's take velocity of a particle is uh, particle is 10 meter. Let's take another value, 5 meter per second along negative z direction. Okay, negative z direction. So what will I write here? I will write here velocity, that is vector quantity. So magnitude is 5 meter per second into, we have to put direction. So direction minus z. So I will write here minus k cap. So this velocity will be equal to minus 5 meter per second into k cap. So this is how we will write in vector form. So we will see lots of application of this one I j k. Okay, so this I j k is unit vector along axis, along x I, along y j, along z k cap. Okay, so this is how this unit vector is defined. Okay, so next one, we will see addition of vector. Okay, so before addition of vector, let me complete multiplication of scalar with vector. So this is short topic, multiplication of scalar with vector. Okay, multiplication of scalar with vector. Okay, so let's take a is a vector, vector a is multiplied with scalar lambda. Lambda is a scalar, means only magnitude. Okay, so if I am multiplying here, so after multiplication, let me say that I am getting another vector b equal to lambda into a. Okay, so this is a scalar. So what will happen? Always this scalar multiplication will be this is lambda times vector a. So I'm saying that this is vector b. So one thing is very clear, v will be always parallel to vector a. This is very clear. Okay, if lambda is positive, this is positive, so b will be parallel, and b will be anti-parallel if lambda will be negative. Okay, so this value is positive, so both vector will be parallel. If this is negative, then both vector will be anti-parallel. Clear? So this is how. Now magnitude of this vector b means, we can write here magnitude of vector b. Magnitude means, I will write here, it will increase by lambda times of magnitude of vector a. That means if you are multiplying by any scalar, that much time magnitude will increase. Okay, so here b will increase by lambda times of a. Okay, so this is how. So we can also write like this. This represent magnitude. This is another way to represent magnitude. If you write vector and mod, this will represent magnitude. This is only later will also represent magnitude. So here this will be b equal to lambda into a also, we can say. So here only magnitude will increase lambda times. Okay, so magnitude will increase by lambda times. Okay, so magnitude will increase by lambda times, and if lambda positive, then both vector will be parallel. If lambda negative, then both vector will be anti-parallel. Okay, so this is how a scalar is multiplied. So we can take example based on this scalar product. Okay, so this one is over. Okay, so example of it, we can take example. Let's say a mass of 5 kg is moving along x-axis with acceleration 5 acceleration, let's take 2 meter per second square. Okay, then find force acting find force acting on mass m. Okay, so find the force acting on mass m. So here we can calculate force value. What is the force value? We know that mass into acceleration, but force is vector quantity. So of course acceleration is also vector quantity. This one is a scalar here. So here this is something like a scalar multiplication of vector. Okay, scalar multiplied with vector. So here mass is how much? Mass is given 5 kg, and this is a 2 meter per second square. And in which direction? X direction, I can take I cap. So this will be 5 into 2, 10 kg meter per second square into I cap, and this is nothing but Newton. So this is Newton I cap. So we got here force. This force is 5 times this 2 meter per second square. Okay, that means whatever is scalar value, that much time vector will increase. Okay, so 5 times this 2 vector will increase. That is how we are getting. So this is example of scalar product of scalar product with vector. Clear? So next one is addition of two vector. So I will cover in next video. Okay.